Okay, so on 27, find the mass that remains after 16 days. Okay, so what did you have to write first? So what is it? Every 4 days, what does it do? It decreases by half-life. Okay, the half-life is 4 days. So half gone every 4 days. Nice. The initial sample is 1 gram. So you start with 1 gram. And after 4 days, that's how much is left, right? 1 gram times 1/2 times 1/2 is how much is left after 8 days. 1 gram, 1/2, 1/2 after 12 days. And then 1 times 1/2 times 1/2 times 1/2 after how many days? So you could do A just by straight out multiplying it out if you wanted to. So what's that going to be? So 16 days. So how much do you have left here? 1 over 16 kg after 16 days. And my handwriting is getting progressively worse. I'm sorry about that. Okay. So B, it says, find the mass T that remains after T days. Okay, so you had to do that out by hand first. Might have helped you there. So after 4 days, how many times do you multiply it by 1/2? 1. After 8 days, how many times do you multiply by 1/2? 2, and then 3, and then? What's the relationship between these numbers here? What? Divide by 4. How do you get from days to the number of times you multiply by 1/2? Divide by what? 4, yeah. So the mass after T days is going to be 1 times 1/2 to the what power if T is in days? T divided by 4. Exactly, right. What can you get rid of? What number there can I just not write? 1. So the mass after T days is going to be 1/2 times T over 4. Exactly. So that's B. Find the inverse of this function and explain its meaning. Again, I ran you up against a wall to see if you'd actually go anywhere with this. So you could say M is equal to 1/2 to the T over what? 4. If you wanted to find the inverse, so this is the mass in terms of what? Exactly. So the inverse, what's that going to tell you? Why would it be very useful to have this kind of function? Give me a situation where this might be useful. You're walking through the woods and you come across a whole big lump of palladium. That would kind of suck for you, mainly because palladium out in the open might not be the healthiest things for you. You look at the lump of palladium and you measure its mass, and then what might you be able to find? How long it's been there for, right? Maybe. I mean, there's a certain there's something similar that's used to date really old things. What's that called? Carbon dating. They measure how much carbon is left in the object, and then they can use nice formulas like this to figure out pretty accurately how old it is. You know that. You've heard of carbon dating before, right? Slightly important. Okay, so in this case, what are we going to do first? We're going to switch. So what are we going to have here? T is equal to
1/2 M over 4.
And what are we going to isolate here?
M over M.
So we want to isolate what? Isolate M. So you don't know how to use logarithms yet. That's a wall. But what could you do here what could you do to clean this up a little bit? Can't really divide by 1/2 here. What could you do? I don't like that 4 in the exponent. What could I do to both sides to get rid of that 4?
Times 4.
Times what by 4?
The exponent.
How do you times the exponent by 4? What operations would I have to do? I have to raise both sides to the 4th. T to the 4th will equal 1/2 to the M. Yeah, that's true. Now you're kind of stuck because you haven't done anything with logarithms, but now do you have a motivation now for learning logarithms? I kind of like this method. Now it's not totally coming out of the blue. At this point, you have an exponential equation. You're trying to isolate something that's this is called the base. It's in the base, actually in the power. Sorry, excuse me. It's in the power. You will need to learn how to use logarithms. That's coming up. So you couldn't go any further, but if you get this far, I'd be proud of you. Mainly what I was getting at here is if you could actually find the wall. Okay. Anything else on the homework?
I'm confused.
Number 5 was what? State the domain and range of the function?
Yeah.
So you had f of x is equal to the square root of 4 minus 3x squared. So what's the first thing you could find?
Domain.
Yeah. You need to have 4 minus 3x squared what? Greater than or equal to 0. So therefore, you know that 4 has to be greater than or equal to 3x squared. So 3x squared has to be less than or equal to what? 4. So x squared has to be less than or equal to
4 over 3.
4 over 3. So x squared has to be less than or equal to what? 4 over 3. So mathematically, you have to be real careful here. Warning bells have to go off in your head anytime you're going to want to do what? What do you want to do next? So you know that x definitely has to be less than or equal to what? Yes. But when you take the... this is not clean here, so that's only half of it. Because when you square something, it's always going to be positive. So the best way to write this would be this. The absolute value of x has to be less than or equal to root of 4/3. You can clean that up again. That's 2 over root 3. And what is that? That's root 2 root 3 over 3. That's more, you more commonly see that. When you take calculus, it's not going to matter as much, but 2 root 3 over 3 is more commonly written than 2 over root 3 because the denominator there is irrational. It's called rationalizing the denominator because now the denominator, 3 is rational, but root 3 is not rational. Side note, root 3 irrational. We'll talk about that in a second. Come back to that. Okay, so what does this mean, though? What does that mean in terms of, so x has to be less than or equal to 2 root 3 over 3, but it has to be greater than or equal to what? Negative 2 root 3 over 3. Yeah, absolutely. There you go. It absolutely has to be between those things, because if it goes beyond that, when you square it, it's going to be greater than 2 root 3 over 3. Does that make logical sense, everybody? Whenever you square or square root something, you really need to take a deep look at what's going on. There's no one thing you need to watch out for, but in terms of an inequality, when you square root, when you square root an inequality, what are you going to have to do to that x? Make it the absolute value. So that's the domain, x such that, can it be equal to 2 root 3 over 3, or is it strictly? It can, because can you have square root of 0? Yeah. When you're thinking about domain, you get so hard-coded into not using 0 in the denominator that sometimes what do I see? You can't have 0 in the square. Yeah, you can. Can you take the square root of 0? Can you take any root you want of 0? Yeah, you can. What's the trick now, though? What's the hard part? Range. We need to find the range, so we find the, what do we find first? The inverse. So we have x is equal to the square root of 4 minus what? 3y squared, right? So 4 minus 3y squared is going to equal what? X squared. So we have, let's put it all on the right hand. I just like making it. So 0 is equal to 3y squared, right? Minus 4 plus x squared. Actually, do you even need to do that? No. There's only one y, right? This is great. You like this. So what do you get? 4 minus x squared is equal to 3y squared. So what does y squared equal? 4 minus x squared over 3. So y is equal to plus or minus the square root of 4 minus x squared over 3. Now, you have to choose, is it going to be the upper half or the lower half? And what's a good way to do that? You have to, this is not a function because of the plus or minus. We talked about this yesterday. The plus or minus automatically makes it a relation, and not a function. Every time you plug in an x value, you're going to have a positive and a negative value output. So that automatically violates the vertical line test. How do you go about choosing which one you have, the upper or the lower? How do you figure that out? What's the relationship between a function and its inverse graphically? What's the graphic relation between a function and its inverse? It's reflected over what? Y equals x. So what could you do? Graph the original function. Absolutely. What could you use to graph the original function? Why is it showing there's a gap? It's so steep. Yeah, it's too steep. The resolution on the calculator can't quite handle it, so it doesn't draw the dot. Okay, so what line should we draw in there? Y equals what? X. Graph this thing, right? Got it? So you just graph this right here. Can you actually answer the question here? Can you actually tell me what the range is? You can actually tell me the domain without actually finding the inverse.
0 to the original.
Yeah. What's the range here? Y such that we know y is between. It's greater than. Can it be equal to 0?
You can.
Yeah, it needs to be less than or equal to what?
2. Yeah, 2.
Look at the graph here. You can actually do this logically. Where's the highest point when x is 0? When x is 0. So it's actually going to be when you plug in 0, you get the square root of 4, which is 2. So did we actually need to find the inverse here?
No.
You didn't need to find it. Another problem here is if you try to find the inverse, what type of function is this? Therefore, it is not what? It's not one-to-one. That's what I'm looking for. If it's not one-to-one, its inverse is not going to be a function. So if we were going to invert this thing, we would need to limit the... Yeah, we'd either have to pick the left-hand side or the... So let's actually find the inverse here. Which side do you want to pick, the left or right-hand side? Let's pick the right-hand side. So how do we limit the domain again on the graph? What do we write? Do you oh, I got to delete that. Hold on. Got to go all the way over here. X, second what? Math, greater than what? 0. Now let's graph it. And now we just have the right-hand side and that. So now could we invert that and still have a function? Yeah, so if we wanted this to be invertible, this by itself is not one-to-one. So to make it invertible, what's the invertible domain going to be that we chose? X such that greater than 0. So if x is greater than 0 here on the domain, what would we need to choose here? Well, first of all, if we're going to make it invertible, our inverse, it's always going to be positive or negative. What do you think? Let's go back here. If we flip this, where's it going to be? The domain here is always positive, so the range of the inverse to be what? If the domain of the function is positive, the range of the inverse has to be positive. So which one are we choosing, plus or minus? Plus. So if we actually choose this here, it's going to be the square root of 4 minus x squared all over 3, correct? And what's the range going to be? We know what the range is going to be, what? Y, such that y is... And what's the domain going to be? That's the question here. What's the domain going to be? Well, the domain of this is the same thing as the range of here. What's the range? Oh, it goes all the way up to 2. So let's guess the domain is going to be x such that x is what? Not greater than. It's between 0 and 2, right? So this is our domain. Let's test it out. Let's see what happens. Let's graph it. So what do we plug in here? What's our inverse? Do you remember what it is? It is, I got to be careful about this, right? The square root of what? Parentheses x squared, right? Divided by. And let's graph this and see what it looks like. So do we need to limit the domain? Yeah, so what do we do? Yeah, but if we type it into our calculator, what do we need here? We know, what's the first limitation? X has to be what? Less than what? What's the first limitation? It has to be less than or equal to what? Less than or equal to 2. So if I do that, that's great. But then also, what else does it need to be? Did we actually have to put that in? No, because if you plug in anything greater than 2, it won't graph it. You notice how the graph stopped at 2? So really, what's the important thing we need to put in here? X has to be what? Greater than what? 0, right. So now if we graph this, here's our original function. Here's y equals x, and there it is. Now, why doesn't it look exactly like you could flip this over? Like, why isn't this line going up here a little bit? It looks like from here that it would have to go up a little bit. Can anybody... This is correct. I'll tell you that this is correct. Can you tell me why visually it doesn't look exactly correct? Like, if you folded the screen, does it look like they'll overlap? It looks like they're going to miss a little bit. What's the problem? Yeah, it has something to do with the window. The window is resulting in something that's a little off. You don't really notice this because it doesn't really matter most of the time. The scale. Look how, like, 1 unit is this far, but 1 unit is that far. It scales it. We're going from 2 to 2, right? what you need to actually do is zoom. I think it's going to be, see square there? It changes it so that the units are the same on the X and Y. Does it look a little better now? Zoom square. Do you see zoom square? But now it's really steep, so maybe I'll change the window here. Let's change it to, what's that? Let's make it like -1 to that, and -1 to 3. Let's graph this. Let's see if this is a little better. Is that a tad better? That's not bad. That's not bad. So let me clip this in. So does that make sense, everybody, how we have to limit the domain in order to make it invertible? Why do we have to limit the domain to make it invertible? It needs to be a one-to-one function. If it's not a one function, is it invertible? No, we're saying it, when we say invertible, it's invertible and the inverse has to be a function. You can, technically you can invert anything you want, but it's not always going to be a, it'll always be a relation. A relation can be anything you want. Yeah.
Honestly, if you find the domain just from the inverse function, according to the √4 minus x squared over 3,
yep,
it's negative 2 to 2.
I understand that, but if you connect this, this part doesn't match down here. We chose right here. We chose this to be our function to start with. That's what we chose. So we were specifically looking for just the inverse of this piece right here. The inverse of just that piece is going to be just this piece of the inverse. If you flip this over the line y equals x, will they overlap?
They will.
They will. If I kept this going, will they still overlap? What? No, they will not. If I flip that blue function with the dotted part over the line y equals x, will it line up with the yellow? No, it will not. It will not.
Oh, because it will not, so then you just...
What would you need? What would you need? You need the yellow to continue down here, right? Is the yellow a function with the dotted part? No. We are dealing with what? Functions. We are staying in the land of functions. Soon, when many of you take calculus, do you get to deal with the land of relations? Absolutely. Not a heck of a lot changes. It's just a little bit more to visualize. Not a heck of a lot changes. But for now, we are in the land of functions. Okay, put everything away except the pencil. Who has an answer to the first one? Raise your hand here. Raise your hand. Who has an answer to the first one? Who thinks they have one? Baldwin, what do you think it is?
Y
Equals what? Just the root of x? I don't think it's that. I think there's more to it. What do you think, Victor?
Like -3 was root of 9 plus 4x squared.
Like that?
No, everything over.
Everything over 2? How many people got that? Anybody else get that? No? Yeah? I'll leave that as a question mark. Okay, you're home. And what about this one? We're pretty good. What do we think here? 5 thinks you think he totally got it. 0 is he totally didn't get it. What do you think? We're pretty good? Pretty good sketching? Okay. Your homework tonight. Finish number 1 above. And 2, write 4 really good Unit 4 questions. This is just 1, 2, 1, and inverses. That's it. Because your Unit 4 test is going to be on Thursday. Yeah, we're done. We're breaking it down real small this semester, real small. Would you prefer we have more stuff in each test? No? Is it okay?